We are on lesson 9-12 in Algebra 2. Today's date is Thursday, March 12th. I'm going to go ahead and put a stop to those conversations right now, but thank you. And hopefully that doesn't get in the way of the notes because I need to leave that up there. All right, so our objective today is to... Brian has it first. Yep. Cyclic nature, or I think it's cyclic. It might be cyclic. So things that cycle. All right, so before we even begin the lesson, what are some things that cycle? Can you guys give me some real world examples of this math? You're always, when are we going to apply this? Well, you don't want to apply it, but you could apply it to the following things.
Coronavirus.
Coronavirus might have a period that goes up and down. Maybe. There's things that definitely have like a strong like correlation between a sine wave and real life. Any ideas? India?
Heart rate.
Say again?
Like the graphs from like stock.
Stock markets, yeah, they can go up and down. Some of them could be modeled, but it wouldn't be I'd have to be careful about how I did it. Oscar?
Would it be smart? I'm talking about the stock market. I don't know if this is off topic.
We'll continue off that tangent. Keep going.
Okay. All right. So let's say the stock market's going down right now, right? And all the stocks are down. Would it be smart to invest and like in a couple of years they'd go back up and you'd get your money?
If they come back to their current prices, then you would make a net nothing. So hopefully you predict that in the future that it would go up. I would, if you have money to invest right now, I highly suggest to not invest yet.
Not yet?
Not yet.
But they're like plummeting. They're like down.
The virus has only spread like what percent of the world? Not that much. And then experts are assuming it's going to be 40 to 70% of the world. So once it hits a higher amount, then is the time.
Like grandparents.
And didn't I show you guys the video on COVID-19, the mathematics of it?
No, I don't think you did.
I'm pretty sure I did. There's a point that they talk in there called the inflection point where you can tell when it's about to end. So if you can actually find the inflection point of COVID-19 and then invest at that time, it'll only slightly go down and then it'll probably go back up. So if you want to use some math.
Is 500 enough to invest in?
Yeah. Yeah, you can buy a few stocks depending on what you buy. It's not enough to buy one share. All right, so what are things that cycle? Here's one, the sun. The sun goes up, then it comes down, then it comes up, then it comes down. I can model the sun or sunlight for that matter with a sine wave. What's something else that is cyclic in nature? Keep it PG, please. Yes.
The moon.
The moon! Oh, that's a gimme. I'll take it. Yes. Other things that cycle.
Your heart rate.
Heart rate. That is very cyclic, and it's more of a discontinuous function, but it is very close to cyclic. I'll take it. That's awesome. What else? Yes, Anna.
Seasons.
Seasons. Perfect. And then within the temperature of those seasons, or the things that are related to those seasons, like clouds and stuff like that. Perfect. Other things. What about a pendulum swinging? Have anyone seen like a grandfather clock that has something that swings back and forth? Or maybe if you're walking like this, how your arms are swinging?
Is that how you walk?
That's how I walk. Don't make fun of me. What are some other things that are cyclic?
Wheels.
Yeah, wheels. Or a Ferris wheel, or any type of wheel, right? Those are all cyclic. So there's a ton of different examples that I can use. What are the ones that we're using today? We're talking about a pendulum in example 1, and planets rotating around other things. That is also very cyclic. Anything that is going around is probably going to be cyclic. All right, so our general formula, we have this down by now, right? Let's do this really quickly. Quiet raised hand. A. What is A? In our general equation, y equals a sine bx plus h plus k. Lorea, A is? Amplitude. Everyone write it down. It's like our 7th time of writing it down, right? Amplitude. How far up and down I'm able to go, the stretch, the vertical stretch of our function. This sine could be cosine, so I'll write cosine underneath here. It could be sine or cosine, depending on what it's telling you. It should tell you in the problem if it's sine or cosine to model. What about B? What does B do, Leo? It affects the period. Everyone write it down. Affects the period. And Leo, do you know off the top of your head what the equation is for period?
Well, I got it. Over B.
Period is equal to, say again?
2 pi over B.
2 pi over B. Nice. Is that what you were going to say also, Aurelio?
Same.
No, you
Okay. Aurelio has verified it. It is
No,
correct.
it's out. He took it.
H. We do not care about H today. We can go ahead and cross it off, but let's go ahead and label it. What is H?
Phase shift.
The quiet raised hand, Aurelio. Aurelio, say it one more time.
Phase shift.
Phase shift.
Sorry, I felt attacked. So it doesn't make
Okay. Well, thank you for participating. I appreciate it. Next time with a quiet raise hand, though. And then finally, K. What is K? Emily. It is the midline. All right. So, other things that we want to know. Midline, that is we can also think of this as the average of the extremas. Which means you do x, or I guess we'll do like y1 plus y2 divided by 2. That's what I mean by average. We know the formula that goes with b, and the formula that goes with a, it's the distance between the midline and the amplitude, or half the distance between the extrema. I think we already know that, though. Let's keep going on to our graph. So I ask this almost every single time because it is very important to know what these things are called. Someone tell me, what is this orange dashed line thing called? Orange dashed line, yeah, Caroline. Label it, everyone. That is the midline. So if you have a point, the point can be on the midline or it can be off the midline. So this is a point that is on the midline. This is a point that's on the midline. Those are all considered to be midline points, I suppose. What about this green dashed line? I think it's green. It might be red. I don't know. This line right there. What do I call that thing, Beverly? Amplitude. Everyone label it. Amplitude. All right. And by the way, all of our laptops should be closed. What about this point up here? The point that is at the very top most of the graph. Who still has a card? India?
It will be the peak or just one of the extremes.
Yes. And give me the third name that's called.
It's
So,
maximum.
yeah, peak. I can call it the maximum. And it is one of the two extremas. I'll just do EXT for extrema. Hopefully that is good enough for all of us. What else can we talk about here? What about this point down here? What are the names for him or her? That's zero? No, say again? Minimum, yes. Let's label it minimum. What are some other names that we can call it? Another required raised hand. There are a bunch of names we can call him. His name is Bob. His name is Fred. His name is George. Ellery.
Who are these characters?
Trough.
Can be called a trough.
Should I say the other one?
Yes, please.
Or it's another extreme.
Another point of extrema. Thank you. Cool. All right, so the final thing that I'm going to talk about in this graph before I move on is how much of the period am I talking about? And this will be 100% of the time true. The midline to the maximum. I don't even care. I can say midline to the maximum, point to two random points. If I tell you midline to maximum, you know it's going to be what fraction of the period. You guys are all going to shout out.
A quarter.
You guys are all going to shout out.
A quarter.
A quarter.
A quarter. Label it a quarter in your notes. The distance from a midline to the maximum, this distance right here is 1/4 of the period, so 1/4 p. What about the distance between a midline and a midline with a quiet raised hand? Midline to a midline with a quiet raised hand. Who has their cards still? I need to get some more cards in here. Oscar. It is 1/2 p, a half of the period. What if I go from a relative extrema to a different relative extrema, so a max to a min, or a min to a max? How much of the period is that? I need to get more cards in. I have almost everyone. Sam. How much of the period is it from a max to a minimum or a minimum to a maximum?
Is it
Not a whole. This distance is about the same as this last distance. Half. Everyone label that this is a half of a period. And that's all we really need to say about him. All right, so let's move on to example number 1. I need a reader. Who wants to read? You don't have to have your card, just anyone will do. Oscar, yeah, read again.
It's not my card.
Oh, who'd you raise?
A card.
Whose card?
Sam's card.
All right, Sam.
I'm not reading.
Okay, quiet raise hand. Who wants to read?
I'll read.
Thank you, Chewy.
A pendulum is swinging next to a wall. The distance dt in centimeters between the bob of the pendulum and the wall as a function of time t in seconds can be modeled by a sinusoidal expression of the form a times sine b times t plus d. At t equals 0, when the pendulum is exactly in the middle of its swing, the bob is 7 centimeters away from the wall. The bob reaches the closest point to the wall, which is 1 centimeter from the wall. 5 seconds later, find D, in parentheses T. T should be in the radians.
All right, so, thank you, Chewy. That was beautiful. Thank you for trying. Everyone can visualize what's happening in our problem. Let's pretend Mr. Sindel's arm is the pendulum because I walk like this. All right, so it's going to be my left arm, and the bob is just my hand, my fist, whatever. So I am going to swing this and pretend to almost hit the whiteboard, and I need to model what's happening with my fist in terms of its height, in terms of the time, everything. So I know before I even start, at time is equal to 0, my fist is straight down. Pictures again?
I just need Ellery.
How long?
I don't know if you know what it is here, but he told me.
Sorry, you'll have to catch up. So my fist is directly straight down when I begin at time is equal to 0. So this is my starting position, my y-intercept, right? Okay, then I'm going to be swinging it. I don't know if I swing this way first or this way first. Do I? Let's see. I know that at the middle, this is the middle, this is an extrema, this is an extrema. So at the middle, I'm 7 centimeters away from the wall. So my y-intercept is 7, right? 7 centimeters away from the wall, and I'm going to reach the closest point to the wall 1 centimeter away 5 seconds later. So I know that I'm swinging back towards the wall immediately, which means my distance between my fist and the wall is going down. I'll say that one more time because that will affect if we're going to a maximum or are we going to a minimum. My fist is getting closer to the wall, so the distance between my fist and the wall, or the bob of the pendulum and the wall, is going down. This distance is going down. I'll say it probably a fourth time later too. And then that happens 5 seconds later when I start swinging back the other way. So all I have is this point, and that's it. And I know I'm a sine function. From that problem, I need to be able to construct a function that models what's going on. Are we ready? Let's do this. So, first and easiest, I'll give an easy one. Are we sine or are we cosine? Sine or cosine, guys? Just read the problem. With a quiet raised hand. Yes, Aurelio.
Is it cosine?
Not quite. You just read there.
I'm not raising my hand again.
It's okay. Here, I'm helping you out.
Sine.
Yes, it is sine because it tells you that right there. Yeah, so sine. Everyone write down sine. And then leave some space. We don't know what the period is. Yes, it is a sin. All right, so in the problem, I started at the middle. Middle sounds a lot like one of these words that we just listed up here on that graph. I would have preferred a quiet raised hand, but yes, you are correct, Leo. It is indeed the midline. So we are starting here at the midline, which makes sense because that's where a sine wave starts. And we didn't label it in our graph, but sine starts at the midline, and cosine will start either at the maximum or cosine will start at the minimum. Cosine starting at the minimum will be a negative cosine. Cosine starting at the maximum will be a positive cosine. And a sine that starts going up is a positive sine. A sine right here that starts going down is a negative sign. So on the graph, we can do a positive, negative, cosine, and sine. All right, so we know that we are talking about the midline.
Oh, I get it.
Go for it. And then I also know that the midline is 7 because I'm at the middle of it. This is plus 7. Okay, so from there, I need to figure out what my amplitude is. What is my amplitude? I start at 7. Right now, the distance between...
Beverly, India. You guys are going good ways.
Sorry, you'll have to catch up. Right now, I'm 7 centimeters away from hitting the wall. I'm at 7 for the midline, 7 for the midline, and then I'm going to move to 1 centimeter away from the midline. Or 1 centimeter away from the board. So I go from 7 to 1. How much have I moved? With a quiet raised hand, how much have I moved between 7 and 1?
6.
Lorea. 6. We subtract them. Everyone write this down. It's going to be 6. 6 is the amplitude, but for a value of A, is A going to be positive or negative? And I told you I would repeat it for a 5th time, so I'll say it for the 5th time. I should be going down because the distance between my fist and the board this distance right here is going down.
Oh.
So sine wave that starts going down, is that going to be a -6 or a +6?
Negative.
It's going to be negative. Everyone label it. It's a -6. We're basically done. We have one more value to find, and it's the hardest piece. So it's going to be something t. Not x, t, because it says d of t in here. I now need to find the period. Again, to find the period, so to find the period, I'm going to use our formula, the old formula that I haven't listed up here, which is the fraction of the period. That doesn't need to be such a big fraction. Fraction of the period is equal to your change in x. So I'll help you find the change in x right now. And the change in x in this case is not x, it's t, so maybe I can say x or t. What is my change in t? Between time is equal to 0 and when I'm 1 centimeter away, you'll have to find the time of the problem. How much time has passed in between that midline and the minimum? How much time has passed between t equals 0 and the other time when I'm 1 centimeter away from the wall? Caroline?
5 seconds.
How'd you get that? That's all I can take for you. Yeah, it says 5 seconds later. So my delta t is 5. All right, now my new question for you is, what fraction of the period was I talking about? Again, I went from a midline to a minimum. Look in your notes, a midline to a minimum.
Ow.
What fraction is a midline to the minimum?
Oh, quarter. No?
I'm not going to call on people that haven't been raising their hands.
Oh.
How much of a period is it from a midline to the minimum? It's either a half or a quarter. It's always one of those two. You got a 50-50 shot at it.
Half.
A quiet race. Oh, no, it's not quiet.
What?
Where's a quiet race? Oh, there's a
You
quiet
pointed
race.
at me.
1/4.
1/4. Thank you, India.
Wait.
I was going to call on you, but then you started shouting
Okay,
out.
you're a half or
There's
a
a
quarter.
difference between a raised hand and a quiet raised hand.
Wait. No. Was it a quarter or a half?
It is a quarter.
I said a quarter the first time. Why'd you say I was wrong?
I didn't say you're wrong. I said I wouldn't call on you because you were not quiet.
Oh, okay.
All right. So I know a quarter of the period is equal to 5, and then I'm going to solve for the entire period. Once I solve for the entire period, I can plug it in over here to the equation that I think it was Leo gave us, 2 pi over b.
Yes, sir.
Thank you, Leo. Okay, what am I going to do to both sides of this blue equation in order to solve for p? Right now, p is essentially being divided by 4. I guess you can say multiply by a quarter. It's easier to think of this as p divided by 4. India?
You're gonna multiply both sides by 4.
Let's do it. Times 4. Times 4, and India, our period is going to be equal to,
P equals 20.
there it is, 20. Now's a good time. Go for it, Hillary. Now's a good time to ask me questions, too. Francisco?
Oh my gosh, you broke it.
Hi. Wait.
This is why we can't have nice
Hola,
things.
Peluca.
I didn't mean to.
Any questions up to this point? All right, if there's no questions, then we continue.
You have to change the setting.
Oh my gosh. Okay, so this P is 20 because this P is 20. So over here in the orange, I say that this P is 20 is equal to that original 2 pi over B.
You have to put it down a little more.
I can also think of this as 20 over 1. Because if I have a fraction equal to a fraction, Ellery, here's a new pencil. And you can go ahead and sit down now.
Thank you.
You put it down like that.
Thank you.
She had it on like the smallest setting.
I have a fraction equal to a fraction. Thank you. When I have a fraction equal to a fraction, I could cross multiply and solve, but there's a faster way. Sorry, Andy, I can't call on you. I got you the last 2 times. Beverly.
You switch hands.
Say it louder. Ellery, I cannot hear Beverly. Say it the 3rd time, please, Beverly.
You switch 20 and B.
Switch 20 and B. So our final answer for B is equal to 2 pi over the switched 20, and I can actually reduce that. Quiet raise hand to reduce. Sorry, India, I've been calling on you too much. You need to spread it out a little bit. Reduce 2 pi over 20. Sorry, Beverly, you did it last time. 2 pi over 20. Someone reduce.
10. One time.
Sam.
Is it pi over 10?
It is indeed pi over 10. Really, I'll call on you again if you have a quiet raise hand. Therefore, our value here for B is pi over 10. pi over 10. And there's our final answer. Done. Box it.
Wow.
So the one thing that students might have missed that went to Mr. Godoy's class is we also labeled where positive and negative sine and cosine are in our graph. Positive sign starts on the midline. Negative sign starts on the midline. The only difference is one starts going up, one starts going down. Positive cosine starts at a max, or negative cosine starts at a minimum. So we did add those to our graph. And then if the sinusoidal function's first extrema is a minimum, this is kind of like a quiz, then what do we know about the parent function and what do we know about the sign of the amplitude? The thing that I literally just said for those people that missed it. The answer is going to be either positive sign, negative sign, positive cosine, negative cosine. Which of those four is it if we know that the sinusoidal function first extrema is a minimum? Valerie. It's a negative cosine. The negative cosine. Thank you. And that negative applies to the amplitude if that is unclear to anyone. That is the amplitude. And then the parent function is cosine. Question, India.
Can you just scroll back up to the
Yes. Okay, this is a good time to take in what was the most important thing that I just went through. You are going to, everyone physically stand up. Oh no, we have to get up. We can't just fall asleep in our chairs. Everyone physically stand up. You will have exactly 60 seconds to talk to at least one other person in a group of 2 or 3. What was the most important thing that you just learned from that first example? Maybe your first, I don't want to give you too many ideas. You have to summarize. Go ahead and spread out throughout the room. Don't talk to someone else right next to you. You cannot talk to you. You cannot talk to you. You need to mix up a little bit. All right, you have 60 seconds starting now. All right, quiet raised hand. What was something important that your group found? Quiet raised hand. I need to hear at least from 2 people. What was the synthesized answer that you have? The most important thing that you took away. It will be different for everyone, I'm sure. India, go for it.
You should check where your starting point is. It's negative cos the other way.
Just pick it up real quick.
Those eyes.
Yes, I agree. That is important to know where your starting position is in terms of the midline and if you're going up or down, right? Other important information. One other person. What was something important that you took away from example number 1? Quiet raised hand. Come on now, guys. You had some good conversations. Yes, Emily. Say that one more time. Oh yeah, so you actually have to read the problem, right? Yeah. Good, all right. Let's move on to our next and final example, Jupiter. I need another quiet raised hand to read. India.
Jupiter's distance, JT, in millions of kilometers from the Sun is a function of time, t in years, can be modeled by a sinusoidal function of the form a times sine, in parentheses, b times d, plus d. At year t equals 0, Jupiter is the average distance from the Sun, which is 778 million kilometers. In 3 years, its closest point to Sun, which is 741 million kilometers away. Find JT. T should be in radians.
All right. So we don't have a pendulum swinging. I don't know what you guys want to be thinking of. Do you want me to like go like this so that I'll be Jupiter?
Yeah.
I'll be revolving around. I don't know, Laria's head. Laria can be the sun. No? Okay. So in general, let's draw a picture. Let's sketch this one out because it's really hard to demonstrate with like out, or I don't know, with my actions, I guess. So let's say that we have the sun right there and Jupiter is definitely a tiny little dot in comparison and it's going around the sun like that. There's our cute little sketch. It is going to be not a circle, but an ellipse. All things are ellipses. When you're talking, well, that's not true. But we'll just assume it is for now. Okay, so give me some information. I need to have 4 building blocks. I need the amplitude. I need the parent function. I need the period, and I need the midline. Can anyone use your mathematical detective skills to give me one of those 4 pieces of information that I can write down right now? Any information about those 4. I see one hand. I gotta get at least half the hands in here. There's something easy that you can do. Give me. There's something with an amplitude, a midline, a parent function. There's something that you can tell me right now. I only see one hand out of a classroom of 15. Now I have 3 hands. I'll wait until I get 7. All right, I got 3 hands. What is something that you can tell me about the parent function? You can tell me the amplitude. You can tell me the value of A. You can tell me the parent function. You can tell me the period. You can tell me the midline. Tell me something, or at least where to look to find that something. Anything at all. How to approach this problem. I still have only got 3 hands out of the 7 that I need to continue. 4 hands.
I can try it, but I'm not.
Okay, I just need more hands. I need more people to be comfortable sharing. These 4, this is the power side of the room, that horseshoe desk. Five hands, we're almost there. I need 2 more people. I'll consider Leo's hand up.
No, sir.
No, okay, I'm at 5 still. I need 2 more people to be willing to find any piece of information about this. And if you put your hand up, then you're good. Leo's at a hand up,
I
yeah?
got you, I got you.
Okay, I'm up to 6 now. You can put your hand down if you put your hand up so you don't have to keep holding it up. I need 1 more person. Oh, there it is. Okay. Brian, go for it.
You're signing the formula?
Go for it.
Sign.
Sign.
See. That's it.
Done. That's 1 piece of the puzzle. We have the parent function. We're 1/4 the way there. We need 4 or 3 more pieces of information. All right. So, does anyone have another piece of information they want to try?
Can I just
Aurelio?
try it?
Yeah.
Alright, so put some parentheses in there,
Put parentheses around. Okay.
and then do plus 778 million. No.
Plus 778 like that?
Yeah,
Yeah, you're correct. How'd you get that?
I just looked at the back.
Oh, okay. Is there someone else that can also explain where 778 came from?
Oh, is that the amp? Midline.
It's the midline. How'd you know it was the midline?
Because on here it says it's midline.
How do you know that wasn't the maximum or the minimum?
Because I
It's
marked
a
it.
K.
It's midline. I know it's midline.
How do you know what word in here tells you midline? And if you don't know, you get to call
Very
it.
good question. I don't know. I just know what's midline from looking
Okay.
at it.
You call in someone that has their hand raised then.
Oscar.
All right. It's gonna be Aurelia, back to you.
Call in someone that has a quiet raised hand this time,
So
really,
it's gonna be
please.
the average distance.
Oh, okay. Oscar actually did have it. Thank you. Everyone underline this word average. Average means midline.
Class, let's go.
No homework?
There is. All right, this should only take about 60 seconds. I guess we can time it right now. So the first thing that we need to know is what is the amplitude. So the amplitude is going to be how far I've moved from this midline of 778 to its minimum. How do I know that it's its minimum? Because it says closest. So closest, that means minimum. And the difference between the minimum and the midpoint is the amplitude. So this is a minimum, this is the midpoint, this is the amplitude right here. That's what I'm really talking about in this problem. So I do 778 minus 741. I can do that in my head, that's 37. So 37. And then I ask myself, is that going to be a positive or a negative 37? Well, am I going down or am I going up? I start at 778 and then I go to 741. I'm going down. Going down from a sine wave is right here, going down, which means it's a negative sign. So I come down here and say that's a negative sine of 37. I'm probably out of time, right? Okay, and then the period. The period is going to take a little bit of time, but if you're really good at doing keep it, change it, flip it, it shouldn't take too long at all. So here we go. We know that it took 3 million years. I'm just going to call that 3. So not 3 million years. In 3 years, it's closest. So the total change in time is 3. So my formula is fraction of the period is equal to delta, in this case t instead of x. So we know that it's going to be 1/4 again of the period. Why a quarter? Because it goes from a midline to a minimum. That's always going to be a quarter, or a midline to a maximum, or maximum to a midline, or minimum to a midline. Those are all quarter. Midline to midline, or minimum to maximum, or maximum to minimum, those are all a half. So a quarter of a period is equal to the change in time, which we know is 3 years. So times both sides by 4, so times by 4, times by 4, multiplied by 4 I should be saying. And these 4 cancel out, and I'm left with the period is equal to 12. Once I know that the period is 12, I set it equal to my other formula, which is period is equal to 2 pi over b. I know that p in this case is 12, and I'm going to copy down the rest of the formula, is equal to 2 pi over b. I'm going to write this over 1 so I can switch these diagonals, and my new equation, my final answer, kind of without simplifying, I guess, is b over 1, which I'm not going to write, is equal to 2 pi over 12. Reducing that by multiplying or dividing the top and bottom by 2 is pi over 6. And there's our final answer. Negative 37 sine of pi over 6t plus 778. Thank you for watching. I'll see you guys tomorrow.